Hi everyone. We're going to determine whether each function represents exponential growth or decay. And basically there's just some rules you have to follow. So for exponential growth, and I'll just write it like this, and your equation is y equals a times b to the x power. So exponential growth, a must be positive, and this is Boolean algebra for and, okay? And b has to be greater than 1, okay? Now for exponential decay, a must be positive. However, b is a fraction in between 0 and 1. And all we're going to do is classify functions as either exponential growth or decay or neither. So we're going to look at this. I'm going to divide this up into exponential growth, exponential decay, and on the next slide we'll do a couple neither. The ones you kind of have to worry about, or not worry, but look at are the decay ones. So basically for growth, we could have something like this. Y equals 7 times 1.2 to the x. Okay? This is my A. This is my B to the x. So for exponential growth, A must be positive, which it is, and my B has to be bigger than 1, which it is. So let me write it down here. A must be positive, and B must be greater than 1. So some other ones we have are y equals 2. 2 is positive, and 5 is greater than 1. I have this one. Here's another one. And do one more. All of these are exponential growth because they follow this rule. So for exponential decay, A must be positive. However, B has to be a fraction, i.e. it has to be between 0 and 1. So here are some cases here. Let's do y equals 1/5 to the x. My A in this case is 1. They just don't put it here. Okay. And my B is less than 1 and greater than 0. And we have some more. Again, A is 1 and B is 2/3. Now here's one that's a little different. And this one can be confusing, but if you know that this is really 1/30 to the x. Because all you're doing, you can, this 30 to the -1 is 1/30. So this one is a fraction in between 0 and 1. And then we have, let's do some more. Y 0.4 to the 1/3. Okay. My A is positive here. And my B is in between 0 and 1. And let's do one more. We have y equals 0.2 to times 5 to the -x. Now here again we have this -x. So remember, I can rewrite this as y equals 0.2 to 1/5 to the x. And that would satisfy our definition of exponential decay. Now for neither would be, it doesn't follow either of these two rules here. So for example, here would be a neither. Y equals -5 to times 4/5 to the x. Okay, in this case, my a is not positive. In fact, it's negative. So this is a neither. It doesn't satisfy either definition. And the main thing you're going to look at is this one. Okay? Let's look at one more. What if I had y equals 5 to the 4 times 4/5 to the negative x? Well, my a is positive, but what we want to do first with this is write this as y equals 5 times 5/4 to the x. Because when you do the exponent for 4/5 to the -1, that really is 5/4. So it might look like exponential decay, but it's actually exponential growth, because a is positive and my b is greater than 1. Okay, that's all. The next video I'm going to do is on writing an exponential function for a graph that passes through two given points. Thank you and have a nice day. Bye-bye.